Hi, it's great to see that the strong promotion and the committed quality improvements of science, technology, engineering, and mathematics, STEM, has won nation and society-wide attention in the United States. Almost 40 years ago, I started learning STEM skills deeply and broadly from my PhD advisor, therefore enabling me to work for IBM, which has the best research lab, to found the integrated circuits company, Etron Technology, where I am still the CEO as well as Chief Technical Officer, to co-found several high-tech companies, 4 of which are now public, to be elected as a member of National Academy of Engineering, and to chair the World Semiconductor Council, and now the Taiwan Semiconductor Industry Association. All these rewarding career achievements trace back to teachings of a worldwide outstanding STEM mentor, Professor James D. Meindl. In 1977, I arrived at Stanford University from Taiwan as a graduate student. STEM was the only and best skill for me to maintain my fellowship. But more important to me at that time was who could be my role model to learn stronger STEM capacities to survive amongst top competition. At that time, semiconductor technology and the integrated circuits were just emerging, appearing promising for electronics and computer industries, but still a very risky career choice. Professor Meindl had been at Stanford for 8 years and built up the world-famous IC lab. His first STEM teaching to me is that in order to approach and realize targeted research results, always find and recognize and hire talented people and incubated the infrastructure and environment for them to succeed. He did this, and therefore we could use the most advanced and profound tools to search for theory and experimental results. With such solid training in STEM, it's no wonder that many of his graduate students later became successful pioneers in the semiconductor industry or educators, such as Larry Gersberg as founder of Zoran, T.J. Rogers, founders of Cypress, Jim Plummer, Stanford Dean, Raphael Raff, MIT President, William Brody, President of Johns Hopkins, and many more. The second STEM teaching is always to define far-reaching visions and open a new research directions, as Professor Meindl has repeatedly done in his career. He formed a multidisciplinary research team to study and search for the ultimate limits of scaling in silicon devices. He defined a hierarchical study from physics, materials, devices, circuits, chips, to systems, so that the potential limits for integrated circuits could be systematically studied. As a result, he was invited by many most influential and prestigious international conferences to teach his study results and gave the entire semiconductor industry guidelines in developing the most advanced technologies. He also wrote a book on micropower technologies regarding using integrated circuits in the early 1970s. While all the worldwide researchers were chasing after performance at that time, Professor Meindl has already pointed out that reducing power was another critical attribute of using integrated circuits. The third STEM teaching I learned from Professor Meindl is to focus on working as a T-shaped way, seeking breadth and depth as he has asked his students to do in their research. As an example of research breadth, in the 1970s, his research group was already working with Stanford Medical School on using microelectronics and integrated circuits to study and derive biomedical phenomena. For example, Levi Gersberg's and my research direction was to design and implement a monolithic IC detector, which was implanted into dogs' bodies, and then by using ultrasonic Doppler effects and telemetry techniques, we could detect how drugs could change blood flow velocities in animals for future therapeutic directions. Professor Meindl has been a true pioneer and successful researcher to lead such interdisciplinary STEM research across the health and semiconductor fields. Regarding depth, for my PhD, he encouraged me to complete a vertical integrated approach on research. And today, I'm still very proud that my dissertation has not only the breadth, but also the depth. I have used this T-shaped mindset to make contribution to human knowledge by pioneering research in using polycrystalline silicon material and its conduction mechanism, and developing related silicon devices, circuits, chips, sensors to systems with biomedical and microelectronic skill, useful for both academic, industry applications. So it's no wonder when I received so many job offers, when Professor Meindl commented favorably on my dissertation as top-notch work, allowing me to receive my PhD degree. While I joined the top IBM Research Center in the 1980s, I was so well trained with deep and broad STEM teachings, knowing how to apply STEM skills to industrial needs and applications. Even up to today, I still use these STEM learnings to start up new technology and the new technical companies in the semiconductor fields, and lead them to public listing and to significantly impact on mankind's needs. So I strongly urge young people that at your young age, you need to pick up some STEM skills which will add value to your careers, no matter what that may be. Last but not least, Professor Meindl also gave me his useful tool to assess what a person should decide for his career or even life path. When I was graduating, I consulted him on what would be the best job choice for me. He told me to spend some time to deeply thinking and define what are the ideal expected results I would hope to achieve in the next 3 to 5 years, at most within 30 to 50 very precise wordings. This is not exactly an STEM issue, but I have realized it is related because I had already learned to do any future assessments using both visionary and quantitative ways as embedded capabilities, just like Professor Meindl has trained me already in STEM practitioner. I did as Professor Meindl told me and went back to see him, and we discussed and changed some wordings in my 50-word future outlook of Nicky Lu's career wishes. Those statements portrayed almost exactly what I actually achieved in the next few years after leaving Stanford. And this methodology still helped me very much in my today career choice or decisions since then. So I'm still using this skill and all the STEM skills I have learned from this wise mentor, Professor James D. Meindl. So, STEM has given so much to my career in life, and I'm heartened to see the United States strongly promote STEM to all young people to strengthen the economic and society by using the STEM skills for all young people's future career. Thank you very much for your attention.